When discussing Amazon Web Services Lambda function storage directories, we often mention /tmp, the only writable storage directory available to your Lambda function. However, other important directories in Lambda are crucial in effective function management and optimization. Let's take a step-by-step look at these directories. Let's first start with /tmp. The /tmp directory provides 512 MB of disk space for temporary storage. This storage is ephemeral, which is temporary and will only persist for the function's execution environment. If the execution environment is reused, that is, the Lambda container is reused, the content might persist between invocations. However, this is not guaranteed. This directory is useful for storing temporary files, caching data, or for any intermediate processing that requires file storage. Common use cases include writing temporary files for processing, caching data to avoid refetching from external services, storing files that need to be uploaded to other services, example S3 after processing. Let's take a look at other important directories /var/task. The /var/task directory contains the code and libraries that you uploaded when creating or updating the Lambda function. This includes the main function code, any dependencies that were packaged with the function. This directory is read-only and is loaded each time the Lambda function is invoked. It is part of the read-only file system provided by Amazon Web Service. This directory is crucial as it contains the actual code that the Lambda function executes. Since it is read-only, it ensures that the function code remains consistent and secure during execution. The other directory to look /opt. The /opt directory contains the content of the Lambda layers that are attached to the function. Lambda layers allow you to include additional code, libraries, or custom runtimes that can be shared across multiple Lambda functions. Similar to /var/task, this directory is read-only and its contents are specified when the Lambda layers are created and attached to the function. Commonly used cases for this directory is including shared libraries and dependencies, adding custom runtimes, packaging commonly used code or configurations that can be reused across multiple functions. Other important directories. There are a few other directories and paths that are part of the Lambda execution environment, such as /var/runtime. Its purpose is contains the Lambda runtime binaries and libraries that support the execution of the function. This is a part of the read-only file system and is managed by Amazon Web Service. Let's see what happens under the hood. When a Lambda function is invoked, the following sequence of events typically occurs. The first step is container initialization. Lambda uses a micro VM-based model to execute functions. If there is no pre-existing micro VM available, a new micro VM is initialized. The Lambda function code is loaded into /var/task. Then attached Lambda layers are loaded into /opt. Second step is execution environment. The runtime environment is set up, which includes the language-specific runtime example Python node loaded from /var/runtime. The /tmp directory is allocated for temporary storage with a clean state unless the micro VM is reused. Next step is handler execution. The function's handler specified during the function setup is invoked. During execution, the function can read from /var/task and /opt and write to /tmp. Any necessary temporary files are stored in /tmp. Termination. Upon completion, the micro VM might be kept alive warmed for future invocations to optimize performance, retaining the contents of /tmp. If not reused, the micro VM is terminated and the /tmp directory is cleared. To sum up the role, understanding the roles of /tmp, /var/task, and /opt is crucial for optimizing your Lambda functions. Each directory serves a specific purpose, from temporary storage to housing the function code and layers, ensuring efficient and secure function execution. By leveraging these directories appropriately, you can enhance the performance and reliability of your Lambda functions. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.